Hi guys, welcome to the channel. I'm the Rusty Casual, and today I'll be showing you how to 3D print models off of the internet. We start off by going to Thingiverse. It's a free website that has loads of 3D models ready to print. And I'm searching for a GoPro Ender 3 mount that'll let me mount my GoPro to the Ender 3 base, and it'll allow me to make time lapses, videos and other such things. I found a suitable one and looked through the pictures and found that this was the correct one for me. After downloading the model, I opened the zip folder, went to files and selected one of the parts and dragged that part into Cura. Cura is a free software that converts your 3D models into G-code. G-code is the basic language that these machines understand. We select the material that we want to use. In this case, I would like to use Petri. I don't want to use PLA because it melts too easily, and I don't want to use ABS because it's too tough to print. After that, we select the nozzle size. By default, the machine is on 0.4 mm. If you put in a larger nozzle, you'll print faster, and if you put a finer nozzle, you'll be able to get more details. But 0.4 is a nice balance in between. We then go into the settings. We go into the recommended ones. This gives us the basics. On the top, we've got the layer heights. Then we have the infill. We have the support and the adhesion. You can see that the object may need a rotation. That's something that you should decide on. The strength is within a layer and not between layers. It should be such that each surface that requires strength is perpendicular to the surface of the printing bed. You could print at 45 degrees or whatever you want, but this is the easiest way. You get clean sides and edges, and also some areas need supports, like the areas we can see through, because the above part would just sag and it wouldn't print correctly. It would most likely be a complete fail if we printed that way. We then slice it, and we can preview how it would look when it's printed from that print preview section on top. You can see over here that there are areas that have extra material. That's in order to hold them so you don't have some failed prints. The printer can print in thin air. We then put in the other object. This obviously needs a rotation, so we'll rotate it in the most sensible direction, the one which allows each plane to have the right strength. When strength isn't required and it's just something that's aesthetic, these things aren't really important, right? So the other things that we'll be looking at are supports, adhesion. You can print a bumper around this. I'll show you guys how it looks with these settings, and then I'll alter the settings and show you how things change. You can see a little raft type of thing around the object. That helps it adhere to the surface, and over there we have the supports, and the options are right here. I'll be deselecting them. This is how it would look without the raft and without the supports. The raft really helps with adhesion to the print bed, really important when it comes to ABS and other such materials, and the supports are important for free hanging areas. You can also alter the layer heights. The more the layer heights, the higher they are, the less the detail is. So a curve will have notches. In this case, I've just increased the detail. you can see that it's become much finer. Over here from this curve we can see much better. When we increase the layer heights, it's going to be full of steps. It's something more visible. You might just need to sand it down more, but if you don't want to, then it's better just to change that. It does print faster when the layer heights are higher. That's something I prefer. For me, it's more about the speed that it happens at. We can also look at the infill. The infill tells us how much the density of the material is within it. We can alter that and have different weights and different strengths, but something around 20% is just enough for most of these things. This is quite a strong material, and if you print fully at 100%, you do have some problems with temperature buildup, and there are deformations at times. Now that you're done on the computer, you can save this file to a memory card, and you can put this memory card into your machine. It's got this little slot over here that accepts a micro SD card. After that, you'd have to put in your material. In this case, I'm using Petri. You'd want to clip the end, so you'd have it as a sharp edge, and that would go into the Bowden tube clean. Even the extruder end might have some problems at sometimes. On the reel itself, you have the material name, you have the optimum printing settings for this material, and you have the temperature. So you also have things that aren't so important at this moment, like the thickness of the material, because we don't really change that much. You then feed the material into the extruder. It's got this spring-loaded lever that unloads the bearing from the motor, and then you're able to feed the material through. I sometimes have some problems with feeding the material through because this is an aftermarket part. My original one broke because it was of brittle plastic, and then it goes into the Bowden tube. You then feed it as far as you can into the Bowden tube till it reaches the hot end. You'd want to start with leveling the bed. So you go to prepare and you select auto home. That brings the nozzle to the home position. It's supposed to be just touching the surface of the print bed, and in my case I might have shifted the machine, so I thought I'd just check it out. I usually check it sideways by checking the gap physically. I could see some light going through, but instead what we'd want to do is we could use a piece of paper. That's the standard method that a lot of people talk about. You take a sheet of A4 size paper and you slide it between the bed and the nozzle, and if the resistance is too much, it means that it's too tight. If the resistance is barely there, you can just start to feel it. That's the right point according to many people. After doing one of the corners, you'd proceed by doing the other points and repeating the process 1 or 2 times. That way you're sure that everything is leveled correctly, because one point can affect the other. In order for Petri to adhere to the surface, what I like to do is I like to take a stick of glue and rub it where the 3D printing is supposed to happen. This is sometimes so strong that I might have to soak the whole thing in water for it to get loose. But it's better to have this than it just slipping off of the glass bed. If you have a flexible pad from the original machine, those don't really need this. They have the right material that allows adhesion, and you just twist it and the object comes off. That's why they're great, these flexible beds. You then select your file from the machine, and it'll start heating up the bed and heating up the nozzle for the optimum temperatures of both. When you went to Cura and you selected the material, this was already happening. It was telling you the optimum material settings, the optimum nozzle temperature, the optimal bed temperature. But if there are issues of stringing, where you have these fine lines between open areas, you would want to adjust this a bit, and that could be set according to what the material says on the sticker on the reel. So you could try that out and you would get some success over there. But if there is stringing, there is over extrusion, and one way of reducing stringing is playing with the temperatures of the nozzle, and that is something that you'd have to try for yourself, and you'd come to know how things work. Always make it a point to watch the first layer being printed, because from the raft you can tell if things are correct. If it takes a curve and the material lifts off, it means that the first layer height is too high. That means that you need to decrease the gap. If the material is not extruding correctly and it looks too thin, then you'd want to increase the gap and make it larger, because that means that the nozzle is smashed to the surface and it's not allowing material to come through. So that's another thing you could adjust a bit. You can also observe the gap between layers. It has to be just perfect, where the material looks thick enough yet it's not lumpy. They're not forming this sort of ridge on top, and the adhesion between the layers is just perfect. The machine comes with some tools. It comes with a set of I would say they're sort of like pliers. They just cut through the material and they help you clean the object. And they also come with a spatula that lets you get the print off of the print bed. I would use a combination of both to pry the 3D print off of the printing bed. But when it's a flexible surface, it's so much easier to print out and release the object. After the object is off of the machine, we can clean out all the supports with a set of pliers, or cut them off, or scrape off any excess material, some sort of mild errors due to temperatures and things like that. And from there, what we do is we sand down any ridges, anything that's too sharp, anything like stringing could be just sanded down and you're good to go. We then add the required hardware to the printed part. That's not always required, but in this case we needed some nuts and bolts. So I've added that, I've mounted it to the machine, and we can see how it works. So thanks for watching. Let me know in the comments what you guys want to see next time. Maybe I'll do one of those keychains that I make, and those multi-layer 3D prints where I change the color. I think I'll try that out next time with the 3D printer. And like, share, comment, subscribe, Thanks for watching guys, and see you all next time.